What if I told you there's a war being fought for your life, right now? As you're listening to this, it's happening inside your own body. A battle against our oldest enemies, disease, cancer, infection. But the soldiers, well, they're so small they're completely invisible. And now, this isn't science fiction. This is the new frontier of medicine. Today, we're diving deep into the nano war for your life.
So, here's how we're going to break this down. First, we'll map out the invisible battlefield. Then we'll meet the soldiers in engineering a hero. After that, we'll follow them into action during the precision strike. And finally, we'll look at what victory really means in winning the nano war. Let's jump in.
All right, first up, the invisible battlefield. Before we can really get the soldiers, we have to understand the terrain they're fighting on. And we're not talking about mountains and rivers here, we're talking about the unbelievably complex, microscopic world that exists inside every single one of us. And this is really the whole idea we're exploring today. Forget about what you think of when you hear the word war. The battles that really decide our health and our future. They're being fought cell by cell, molecule by molecule. It's a complete shift in how we have to think about medicine.
So just how small are we talking? I want you to try and picture this. Take a single strand of your hair. Okay, got it? A nanometer is about 80,000 times smaller than the width of that single hair. We are operating on a scale so tiny, it's almost impossible to comprehend.
And this is the key. This is the technology that lets us play in that sandbox. Nanotechnology. It's not just about making things smaller. It's about building things from the atom up, which gives us this incredible, unprecedented control over matter. What that really means is we can now build tools small enough to go head-to-head with a single virus or even a single cell.
Which brings us right to Section 2, Engineering a Hero. Okay, so if our body is the battlefield, then every war needs soldiers, right? Well, scientists are now engineering them, literally creating microscopic agents that are designed to fight for us.
So, let's meet our protagonist, the nanobot. And I know it sounds like something out of a movie, but this is real. It's an engineered machine on a microscopic level designed to do one very specific job, whether that's delivering a tiny payload of medicine or hunting down a rogue cell.
So, how in the world do you build one of these microscopic heroes? Well, it's actually a pretty logical process. First, you identify the enemy. Let's say it's a unique protein that you only find on the surface of a cancer cell. That's your target. Step 2, you design the vehicle, a nanoparticle that can travel through the body. Step 3, you load it up with the payload. That's the weapon, like a really potent drug. And then the final, most important step, you program the mission. Think of it like this. You're giving the nanobot a special key that only fits the lock on a cancer cell. It'll just float past all the healthy cells, completely ignoring them, until it finds that one perfect match. And only then does it unlock and deliver that payload. It's precision engineering on a whole other level.
And this right here, this is the best way to understand why this is such a game changer. Traditional treatments like chemotherapy, they're often described as carpet bombing. Yeah, they're powerful, but they cause so much collateral damage to healthy cells. That's why the side effects are so rough. Nanomedicine, on the other hand, is like a special ops mission. It's one clean, precise strike directly on the enemy target, leaving all the innocent bystanders, the healthy cells, completely unharmed.
Okay, so we've engineered our hero. Now for the really exciting part, the precision strike. Let's actually follow our little nanobot on its mission, deep inside the body.
The mission parameters are crystal clear. Seek and destroy. The target? Malignant tumor cells that are threatening the entire system. You've got to admit, it's a high-stakes operation with absolutely zero room for error.
But look, this mission is anything but a walk in the park. The battlefield is hostile. Our nanobot has to somehow evade the body's own security force, the immune system, which could easily mistake it for an invader and wipe it out. It has to navigate the chaotic, turbulent highways of the bloodstream. It has to find that one specific enemy cell among trillions of healthy ones. And only then can it release its payload effectively. I mean, every single one of those steps is a huge challenge. And it's not just me saying this stuff. As one expert puts it, we are essentially creating microscopic robots that can perform surgery on a cellular level. Just pause and think about that for a second. Not just delivering a drug, performing surgery on an individual cell. The level of precision is it's breathtaking.
And when it all goes right, it is a perfect success. Mission accomplished.
The nanobot finds its target, it uses that special key to latch onto the cancer cell, and it releases its deadly payload. The tumor cell is destroyed, and the healthy tissue all around it, completely unharmed. That is the revolution.
Which brings us to our final section, winning the nano war. So what does the future actually look like when these special ops missions become the normal way we do things? What does total victory over these diseases even look like?
And you have to understand, this tech isn't just for cancer, not by a long shot. Take a disease like Alzheimer's. The huge challenge there is getting medicine past the brain's natural defense shield, which is called the blood-brain barrier. But we can design nanoparticles to act like tiny Trojan horses, sneaking right past those defenses to deliver treatment. Or think about bacterial infections. As antibiotic resistance becomes a massive crisis, we can unleash nano agents that don't even use chemicals. They just physically find the bacteria and rip them apart. It's a whole new arsenal in our medical toolkit.
So really, if there's one thing to take away from all this, it's this. Nanotechnology represents a fundamental shift in medical strategy. We're moving away from brute force, blasting, poisoning, and cutting, and we're moving towards a new strategy of intelligence and incredible pinpoint precision. It's about outsmarting disease on its own turf.
So this is the thought I really want to leave you with. We are right on the edge of using our absolute smallest tools to win our biggest victories against disease. It's a future that is just full of promise, but it also opens up a whole host of new questions about how we control such powerful technology. So the question is, are we, as a society, truly ready for the power these microscopic soldiers are about to give us?